In this video, I will give you a brief introduction into wide and long data formats. Imagine you have the following situation. You have a number of patients, and for each patient, you have some basic data. Let me draw this on my screen. So you have, for example, patient 1, and you have their gender, like male, and the age, say 78, and you have another patient, patient 2, who is a female, and 67. And then for each patient, you make 2 visits. For each visit, you have a date on which the visit was made. Then you have the weight of the patient in kilograms, and you have C-reactive protein. And the same for visit 2. So for the patient, you have also visit 2, also with C-reactive protein, also with weight, and also with a date. Now we have also the same stuff for patient 2. How do we represent this data? There are several options, and which one to choose depends on what you are doing and what you want to do with the data. One option, for example, would be that you have all data for one patient recorded in one row. So you have patient 1, and then you have in your table, then you have for this patient 1, you have the age, then you have the gender, then you have visit 1 date, and then you have, for example, 3rd of March to 3033. Then you have visit 1 weight, you have visit 1 C-reactive protein, etc. And then you have the same stuff for visit 2. And then for patient 2, you have a separate row for the patient 2, and you have the age 67 and gender, etc. This representation we can call a wide representation, because you have plenty of columns, and as you can see, these columns are fairly complicated, because apart from having, for example, a column for visit 1 weight, we might have also a separate column that tells us the units of the weight, whether the weight was measured in kilograms or pounds or whatever else. And the same goes for C-reactive protein. Then we have a date. Then maybe we have some additional information about the data. So it becomes a very complex structure, which is not easy to process. What if we want to know whether the weight of the patients is higher on visit 2 than on visit 1, maybe as a result of a treatment? This data format is not particularly suited to do that. An alternative would be to have each measurement in one row. So, for example, we have for patient 1, we have a measurement. We have a column called visit, and then we have visit 1, and then we'll have a separate row for patient 1 and visit 2. We still have the same column for age, and this contains the same values in both for both rows. Then we have a column for gender, and also contains the same data. Then we have, for example, the date of the visit, which can be different for the 2 visits. We have the weight, which is actually the thing that we are interested in, that maybe, for example, 65.3 for visit 1 and 67.8 for visit 2. And then we can have, for example, additionally the unit, like kilogram. Or even better, instead of writing here the weight, we can write here the value, and then here in an additional column we can write whether it's weight, or in a different row, C-reactive protein. So for each patient, we have plenty of rows. Each row corresponds to one measurement. So instead of having many columns with all the measurements, every row contains only one measurement. For example, measurement of weight on visit 1, measurement of weight on visit 2, measurement of C-reactive protein on visit 1, measurement of C-reactive protein on visit 2. This format is, we can call the long format. What are the advantages of a long and a wide format? So wide format has many columns and then only one row per patient in this case, and it's compact. And sometimes if we select only the columns that are, for example, corresponding to C-reactive protein, it might be useful for certain types of analysis, like, for example, PCA. On the other hand, long format is where we have several rows for each patient. So each observation is in one single row. And this format has several advantages. First of all, it's often easier to filter. For example, selecting a particular type of measurements. It can accommodate more features. So we can include all the metadata about a particular measurement very easily. So additional metadata. Unfortunately, it's not very compact because we repeat data. For example, the age of the patient, if we want to include this in this format, will be repeated on every row corresponding to this patient. This is not optimal. However, there are certain statistical tests or certain analyses that need that format. For example, if you do any kind of regression or plotting with ggplot, this will be the format of your choice. What I'm saying here is we cannot say that one format is absolutely better than the other. Depends what you're doing, and depends in which particular situation. Usually, the long format is preferable because it is much clearer what is in one row of that format. That it always refers to one particular observation. In some situations, you need multiple data tables, actually. You need to have one that describes the patients, for example, their age and their height, on their gender, and a separate data table with the measurements. In any case, you have to know how to convert between those two formats. This is one of the most complex and at the same time most frequent tasks in basic data science.